right, everybody. Good morning to you guys. I'm just trying to get some of this stuff all loaded into our create a new note. Okay. Into Notability. All right. So, ladies and gentlemen. Okay. Just looking over a few things here. Okay. Notability is coming up. So maybe we just go over it since I'm in the browser at the moment. We're going to look at today hypothesis testing about a mean for a large sample. So I'm going to put this in the browser here for you guys. Okay, here you go. You guys ready for this warm up here? This is what we did yesterday. Now, the first part is going to be your hypothesis, right? So what is it saying here to you guys? What does it say? The proportion of what? Portion of students who arrive on time is what? 75% as claimed by what? Snodgrass. You guys okay with that? I'm going to put that claim in red or I don't know, red. I usually do red. So this first portion is this is where you start. So you guys tell me, what parameter is proportion? P. Okay. What do you write down? P equals what? And that's the what? Claim. Okay, you guys okay with that? Is that pretty simple? All right. Okay. So, ladies and gentlemen, here's the deal now. Where do you put that claim? Because we got to set up the hypothesis. So I want you guys to note in your procedure here, and I kind of wanted to write this down. I'm going to put it over here. Hypothesis testing, step number what? 1. Set up your hypotheses. And that's when you write down the H1 and the H0 and the H1. Okay? Now, step number 2, you're going to create your decision rule based on the level of significance alpha. All right. So that's the second step, but you say, well, how do I know what alpha is? They're going to what? They're going to tell you. What did they just tell you? That alpha is what? 1%. Okay? So when you go through this, you're going to set up your bell, and, we haven't set up the hypothesis. This is everything we're doing here, right? This is what we did yesterday. So where does this claim belong? What kind of hypothesis is this? Is that a null or is that an alternate? How do you know it's a null? Good. So far, so good for your first step? Isn't that what we did yesterday? Okay, now what else did we do yesterday? What's the logical opposite of equal? Good. That goes there. Is that true? You have set up the hypothesis, ladies and gentlemen. Okay? You've done this first step here in your hypothesis testing procedure. This is the classical approach. Anybody have any questions on that part? Any questions? Now let's ask you a question here, because you have to create your decision rule. Okay? And when you create your decision rule, you always look at the what? Alternate hypothesis. I'll put a purple eyeball there. And if you see not equal, what does that mean? This is a what? Two tail what? Test. Always, always, always. What do you look at? Alternate hypothesis. Good. Okay. So then what do you do then? You have to draw what? Two tails. You guys draw two tails there? All right. What do I do in the middle? What do I put there? This is what you always write down. Do not reject your null. That's what you always write. That's in the middle. What do you guys put over here? Reject the null. You put here reject the null, ladies and gentlemen. This is your rejection region. But you're not done with your decision rule, ladies and gentlemen. You're not done. Why? What was alpha? 1%. What does that mean if alpha is 1%, right? Remember, half is in, this is alpha divided by 2. So this is 1% divided by 2. Do you guys know what that is? That's 0.5 as a decimal percent. Now, 0.5 as a decimal percent, it's 0.00 what? 5. So the reason I bring that up, isn't that in your tail over here? So here's you're going to have the what? 0.5%, and here you're going to have what? 0.5%. So what you're looking for now here is these special numbers, right? We're almost there. Anybody want to tell me from yesterday, how do you find these things? First of all, what are they called? What are those things in red called? What does CV stand for? Outstanding. These are critical values. So I'm just writing this in our notes. We need the critical values. How do we get the critical values here? Always, always, always. What do you guys use? In the TI. You don't use the table anymore. What do you guys use? Inverse norm. Good for you. Don't use the table. We moved on from the table, ladies and gentlemen. We've moved on. No more table. Just the inverse norm function. Okay, so here's the deal now. Let's go to the TI. Second distribution. Inverse norm is number what? 3. Now, how do I use this? We're going to do the default because I can kill 2 birds with 1 stone. Oh my God, Mr. Judge, you said that. It's a saying. I don't kill birds. All right. What do I mean? Kill 2 birds with 1 stone. It's horrible, but area to the left of the critical value. What's the area to the left of that first critical value? 0.00 what? 5, because isn't that 0.5%? Okay, so in the TI, you're going to put what? 0.005. Yes, you're going to use mu as 0, sigma 1, because yes, this is a z distribution, the standard normal. And I just described that 0.5% numerically is being in the left tail. Is that true? So then I hit what? Paste. What do you get? We're going to go out to the nearest thousands for negative 2.576, ladies and gentlemen. Okay? I already put it down. What's the other critical value? Because there's two. Positive, positive. So, ladies and gentlemen, I want to emphasize this to you guys here. This whole thing. This is called your decision rule. Okay? That's your decision rule. Critical values are part of this decision rule. So everything you guys see here is what they asked us to do. It's what we did yesterday. All right, you guys okay with this? So that's where we left off. And if you said, I want to see your notes, Mr. Judge, well, maybe you do, maybe you don't. I don't know. We were working on two-tailed tests. Is that right? So I just want to go back here in my notes because there's a lot of notes I put here. This is kind of where we left off. This is the decision rule for, where is that? Here's 10%, 5%. I guess I went to the tenths there, 2.57, 2.58, doesn't matter. It's going to be what we just gave you guys, really. Negative 2.576, positive 2.576. Just to let you guys know, this is where we left off. This is your decision rule. Okay? You could use 5.8, but use 5.76. It's by tradition, and you might say, why by tradition? Well, because by tradition, we used to use this Z table to find this stuff. And it was all, if you guys see some of the numbers here, this is where they got it. But, we're not talking about how to use the table. We're just using inverse norm. So, these are kind of my notes. This is all about a two-tailed test. So what I want to do today is give you guys more information here. I want to do a hypothesis test because there's other steps, okay? So in your steps here, put down step 3 because you say, what do I do now after I did the first 2 steps? This is the classical approach to hypothesis testing. See, we're going to test the person's claim, ladies and gentlemen. Let's go back and think. People make a lot of statements. I don't know if you guys noticed. People say a lot of things. They don't even need very much justification for what they say. They just say stuff. They make a lot of claims. But in order to make a formal claim, which is a hypothesis, and then have that tested, because this is really the scientific method, in case you guys didn't know. We're looking at what's called the scientific method. In science, you just can't make the claim. You can't. It has to be what? Tested. So here's the test, right? Step 3 is you're going to take a sample. Okay? And you might say, what do I do with the sample? That is to compute a test statistic. So you take a sample to compute a what? Test statistic. So I always put my samples, as you guys notice, in red, and then now you're going to compute a what? A test statistic value. Now, you don't really, with these questions and homework questions, you don't go out and take a sample. They give you sample information, right? Just like in estimation, they give you sample information. Okay, you guys okay with that? Estimation, they give you sample information. But the test statistic, traditionally, this is a formula. I'm not going to show you the formula here, but as you really say, these are formulas. I'll show you guys in the notes. So there's formulas. This is the general procedure. Step 3. So I'm going to give you, okay, we're going to take a sample, compute the test statistic. Now, once you do that, step 4, you draw your what? Conclusion. Based on where your what? Test statistic lives on the decision rule. This is the last step. You take a sample. Yes, it's a formula. You put your sample information in your test statistic. You're going to see where the what? Test statistic, that thing in purple, lives on the decision rule. You might say, what decision rule? The one you just created. All right? So just to paraphrase, a sample is gathering data so that you can actually draw a conclusion about the claim. What's Snodgrass's claim? Snodgrass is saying the proportion of students who arrive on time is 75%. Okay. Now, here's the rest of the phrase. You guys ready to do the rest now? Here's the rest of this. They're going to say this. This is going to be a part of the question. Okay. So I'm just going to put here in a box. Well, I don't have any space. Here's my hypothesis. Here's my what? Decision rule. Okay. So they're going to say this. They're going to say a sample now of 120 college students reveals that, let me double check here really quick. I'm sorry. Which one are we doing here? Here we go. I'm just looking at some notes here, kind of going to draw them down. Looks like our internet service is slow. All right. Okay, here we go. So a sample of 120 college students revealed that 85 arrived on what time? So what are they sharing here with you guys? Sample information, is that right? Aren't they sharing with you guys some sample information on this? Sample of what? 120 college students reveal that. What does 85 represent? Anybody know? What does that mean? This is what? Is that the percent? No. No, remember they're taking a sample and they gave you the sample size. What else is this? This is X. Good. Remember that, ladies and gentlemen? Sample proportion is what? 85 out of 120. The definition is X over N. Is that right? Okay. So you said, Mr. Judge, here's my sample information. Okay. What do I use now? So what I did here is I went to, this is going to be what we work with. I don't think I put that in our notes, but let me go back. Yes, hypothesis testing procedure. All right, where is this here? Let's put that in the notes. This is the one we're working with. Not sure. We're going to work with the hypothesis testing about a proportion, large sample. That's where we start. Okay. Now, you say, Mr. Judge, you just told me take a sample and to do what? What do I do with the sample? We compute a test statistic. That's a number that lives on our decision rule. So we need that test statistic value. Now, where do we find it? Well, if I go back to my notes, right in here, don't look at that. That's a different example. Don't look at that. That's how we get our decision rule. That's a different example. You know, okay, whatever. We're going to use, ladies and gentlemen, in the TI for your test statistic, 1 proportion z-test. Okay? 1 proportion z-test. I'm going to say that again. 1 proportion what? Z-test. So we're going to have to access this. The procedures are there. How do you get there? You go where? Stat. Scroll over to what? Test. And then I need to go down to what? 1 proportion z-test. You guys see what comes up? So what I now have to do is explain to you guys, what are you guys looking at, okay? Because we're going to have to take a look at this. You see that first line, what does it have? You see P sub 0? Okay, I'm going to share with you guys what's P sub 0. You know what P sub 0 is? Go back to the null hypothesis. You see the null hypothesis right in here, this H naught? I'm going to put it in green because it stands out. The proportion in the null hypothesis is P naught. So what is that? 75%? How do you guys write 75% as a decimal? Point what? There you go, 0.75. Good job. You're on your way. I think that's the hardest part. You tell me, why is that the hardest part? Could you guys tell me what's the value of x now? What's x? 85. That's coming from the sample. That's the number of successes. Good. What's the sample size? Good, 120. Is that right? Didn't they tell you that? A sample of 120? Good, good. So far, so good. Now, you see, this is the kind of test that you have. The proportion equals P naught. That's a two-tailed test. Proportion is less than P naught, proportion greater than P naught. All you got to do is know one thing. This is a two-tailed test, and that's the not equal. Do you guys see the not equal sign there? That's what you guys use. Because it's a two-tailed what? Test. Now what do you guys think you're ready to do? Hit calculate. After you hit calculate, do you guys know what the test statistic is? It's going to be that z value. What is z approximately? Negative 1.05. Go out to the thousandths, ladies and gentlemen. It's negative 1 point what? Negative 1.054. Did you guys see? It's the second line. That is called your what? Test statistic. And that is what we're looking for. That number, negative 1.054. Okay, you guys okay with that? That's what we're looking for. Now, I'm going to go up here and I'm going to copy some of this stuff down because it has a lot of, I don't want to get rid of that. Well, let's just use it right here. And I'm going to get rid of all of this. Okay, so it's not distracting. Where does that z number, okay? See how this is the z distribution? I'm going to kind of label some regions here. Pink. Right in here. Where does that number, negative 1.054, live? Where does it belong in that real number line? Was it negative 1? What was our test statistic? Negative 1.054. Okay, I'm going to write it right here. Where does that live on this real number line? Do you guys know? It's negative, so it's to the left of 0. Is that right? But is it past this negative? Is it past the critical value? No, it's not. You guys okay with that? So it's kind of like somewhere over here maybe. Is that right? That's the z value, the test statistic, okay? That's the number negative 1.054. Do you guys agree with that on the real number line and that z? Do you guys agree that's where it belongs? Okay. Now, what neighborhood is this in? Because we computed the test statistic based on the sample. What neighborhood is that in? You're looking at it. You're looking at this right here. What's the neighborhood? It's what? Do not reject what? The null. So I'm going to write this down for me because do not what? I got to talk about this. Reject the null. See, we're doing the last step. We're going to try to draw our conclusion based on the test statistic. And so this is in the do not reject the null neighborhood. Now, what does that mean? It's in the do not reject the null neighborhood. What does it mean in terms of the conclusion? So here, it's a very simple thing, but people kind of it takes some time for some people to understand it. It's very simple. Do you know what it means to not be rejected? To be accepted, is that right? So if they say don't reject the no, what are you doing? Aren't you accepting the no? Okay, I'm going to say that again. To not reject the no means you're accepting it. You're not rejected. Have you ever been rejected before? What does rejection mean? Push away? Well, you're not pushing away the no. You are accepting the. Don't push away the no. Where is the no? Right here. So you say, you know what? No. You did not get pushed away. You accepted the no. Is that okay? Now, I'm going to go back down in our notes because what are we doing? We're trying to draw our what? Conclusion based on where your test statistic lives on the decision rule. You want the conclusion based on where the test statistic lives on the decision rule. So here's your conclusion, ladies and gentlemen. Here's your conclusion. It's going to be very simple. The conclusion is this. There's only going to be two types. There's only going to be two conclusions. You can say this. The sample supports the claim, or the sample what? Does not support the claim. So ironically, there's going to be only two things. One of them is the right answer. Either the sample does what? Support your claim, or the sample what? Does not support. Those are the key phrases about the conclusion. And it's all in regards to the person's claim. So do you guys happen to know what the person's claim was? What's the person's claim? The claim was the proportion of students who arrive on time is 75%. So I'm going to make the claim myself. It's a different claim that you guys know this answer based on what you're looking at. Everything that you're looking at tells you what the conclusion is. What's your conclusion, ladies and gentlemen? What's the conclusion? The sample supports the claim. Yeah, how do you know? What did we just embrace? The claim. So formally, you guys say this. The sample what? Supports the what? Claim. You say, why, Mr. Judge? Because what did you just do with the claim? You embraced it. Is that right? There it is. That's it. This is your first what? Hypothesis testing question in your life. The first one. Easy peasy lemon squeezy. It's the first one. But as you guys can see, I have to give this to you in bite-sized pieces. And all you got to know, again, is a new what? How to compute that test statistic. That's a new TI calculator command. One proportion what? Z-test. Because the alternative is, if you guys looked at my notes that I spent time writing, where are you notes? See these notes? Yes, you got right tail test, left tail test. We're not there yet. But you know the formulas for test statistics that we used to use in the old days? This is what we used to use in the old days. You'd have to compute that punch all that stuff in a calculator. And then that's how you computed the test statistic in the old days. And you had a test statistic about a proportion. You had a test statistic about a mean. Okay. You have test statistics about two independent proportions, test statistics about two independent means. So in other words, there were various formulas that we used in the past that we no longer use. All we're going to use is the what? TI calculator. There it is, ladies and gentlemen. And we're not even going to use the Z table. We're not even going to use the Z table anymore. You're going to use the TI calculator. That's it. One proportion Z-test. Now, you say, Mr. Judge, this is too much for me. Do I get to use a study guide on my... Yeah, I give you guys a study guide, but what else do I give you guys? Remember this thing? What is this? Do you guys find this helpful? At the end of the course, you're going to say yes. I'm trying to download it. You go, oh my God, Mr. Judge, what do you got? You got some stuff here. Oh, we got probability odds. I'm going to have to add to the formulas here, by the way. Oh, we had language. And I got my summary sheet for you guys. See this? Oh, sorry, you can't see this in the people at home. So, here's binomial, here's Poisson, normal distribution, inverse norm, estimation. That's one proportion Z interval. That's not Z test. Z interval. Oh, hypothesis testing about a proportion. How do you find critical values? Inverse norm. And then the test is one proportion Z test. And then you have others. So, you guys might want to take a look at this as you do your homework. Download that for yourself because, that's what I would do if I was a student. And I was a student. And there it is, ladies and gentlemen. We're going to try one more. What do you guys think? You guys ready for another? Aren't you guys excited about this? You guys are now doing something significant. You don't know how significant this is. Okay? This is the scientific method. But the scientific method is used elsewhere. In other words, you might say something like this. They might tell you guys this, for example. Here's another example of a hypothesis testing about a proportion. So this is going to be hypothesis test about what? A proportion P. Now, what is that going to be? How about this? The proportion of, I don't know, Big Bear residents who believe in Bigfoot. Is not 50%. Okay? A sample of 200 Big Bear residents reveal that 65 believe in Bigfoot. Use the 5% level of significance to test this claim. So this is really how you see a hypothesis testing question. So give you guys some time to write this down. And again, this is going to be what we call a two-tailed test, just so you guys know. Okay, you guys okay with that? It's a pretty simple procedure. Look, I've had a lot of success with students in the past doing this. There's no reason to think you can't be successful. You know, we're going to go through the process. So how did we start this? You guys remember? The proportion of Big Bear residents who believe in Bigfoot. What is this? Is not what? 50%. I should have put as claimed by Snodgrass. Sorry, I left that out. As claimed by Snodgrass. I want to do that there. Let me put that in. Good old Snodgrass. Okay? Now, why do you think I do that? Because, well, it's important because when you go back, here's the thing about it. Like I said, I have a lot of, I've been teaching this topic for, oh my God, I don't want to tell you. If I say, I have experience, ladies and gentlemen. There's nothing like experience. Trust me, nothing gets by me. You think it does, but it really doesn't. It's called experience. It's not anything. Here's what I mean. Well, write down, what's the claim? Notice the language I just used. What is the claim? This is a person's claim. This is the statement we're testing. Remember, people say a lot of stuff in this world doesn't mean it's true. You got to test it. Okay. So what do we do? P what? Good job is not equal to what? 50%. And this is my what? Claim. I write that down. Do that. Follow my steps. Write it down. All right. Remember that first step? You set up your hypothesis. Set up the hypothesis. H naught and H1. Where does that claim go? Because you're going to test this statement. You're going to test it. Where does it belong? Is that a null or is that an alternate? Huh? Okay. Put it in the alternate position. Now, remember, what do you do now here? The other hypothesis, these two statements must be logical opposites. So if H1 is not equal, what's H naught? There you guys go. Look at that. You just set up the hypothesis. That's the first step. Easy peasy? Okay, this is what we've been working on. Is that right? So we've been working on it. Now, today is the first time we introduced a sample, but we can't go straight to the sample. What do we got to do? Second step is to create your what? Decision rule. Draw your bell. Draw the normal distribution. Okay? But really, what people ask me at this point, they'll say, Mr. Judge, is this a two-tailed test? And I'm going to say yes. This is two tails. How do I know? You always look at the what? Remember how I put the eyeball? I even put my eyeball there. Put what? That's not equal. What is, if that's not equal, that's a what? It's a two-tailed test. So draw two what? Tails. What do you put in the middle here? And what goes in the tails? Okay, you guys okay with that? All right. But we don't have a decision rule yet. Why don't we have a decision rule? What do you guys need? You need some what? Critical values. We need those threshold values. Now, you need to know what if you're going to use inverse norm. What is alpha? Alpha is 5%. Good. What's half of alpha? What's half of 5? Good job, 2.5%. So 2.5% is going to go where? In the left tail, and 2.5 is going to go where? In the right tail. What's the decimal representation of 2.5? Okay, isn't that, you guys got that here? 0.025, you guys okay with that? Don't you need that information? Right? So why do we need it? What are we going to have to do? How do we get critical values? You guys tell me. How do we get them? Inverse what? Norm. Do I even have that? Look, let me see if my, you go, okay, Mr. Judge, you made this sheet for us. Jesus, you stood up all night. You made it. I even put that in your sheet there. Critical values, what? Second distribution, what? Inverse norm. Man. I don't know what else I can do. Second distribution, inverse norm is number what? 3. Okay, what's the area again? 0.025. Yes, it's the z distribution. Mu 0, sigma is 1. Is that a left tail? Is that in your left tail, that portion? 2.5%? Say yes. Is that true? We're looking at this. Isn't that to the left, ladies and gentlemen? Right, you see what I'm saying? Okay, good. Let's go to the TI now. Okay, now in the TI, we do what? We say left, paste it, enter. Negative 1.96, nearest hundredths. What's the other one? Positive 1.96. Why? Because of what? Symmetry. So what you're doing here is necessary in hypothesis testing. Okay, you guys okay with that? You guys need this. That's your decision rule. We're all set. What are we all set to do? Take a what? Sample. And then compute the test statistic to see where it lives on the decision rule. And that's it. So now, let's get our sample. What does our sample say? Sample of what? 200. What does that mean? Sample size. Okay, 200 big bore residents reveal that what? 65. What's this? Good. How come you know that? How come that's not a percent or proportion? You don't, it doesn't say percent, does it? Okay. So there's two numbers in the sample. Sample size, success is 265 residents. 65 residents said they believe in Bigfoot, ladies and gentlemen. Okay? Let's test to see Snodgrass's statement. What do you guys use in the TI for that test statistic value? What does the TI say? 1 proportion Z what? Test. Okay, I put that in your notes. I put that in your, where is it? Browser? Summary sheet. All that's left for me to do is just do the test for you. And some of you guys would love that. Say, Mr. Judge, can't you just do the test for me? Anyway. Here we go. You guys ready? What do we do? Stat. Test. 1 proportion Z test. You guys see that there? And it kind of makes sense. You guys know why it makes sense? 1 proportion, 1P, Z distribution, and then hypothesis test. Okay. But I need that P naught again. Yikes. Who can tell me what is P naught? Where do I find it? Where's my P naught? Right in here. I'm going to color it green. It's the proportion in the null hypothesis. However, use what? Use the decimal. 0.5. Now, how many successes again? 65. What's the sample size? 200. Is this a two-tailed test? That not equal is a two-tailed test. Not equal. Isn't it a two-tailed test? Yes. Then hit what? Calculate. Ladies and gentlemen, what is the test statistic? Negative 4.4. You know what commonly people ask? Where do I approximate? You approximate to the same place value as your critical value. So if the critical value is to the hundredths, approximate this to the hundredths. So negative 4 point what? 9 what? 5. Do you guys want to know what the sample proportion is, by the way? It's going to be 0.325. Do you guys see it down there? It's second to the last. You guys see it? That's the sample proportion. 32.5%. Okay? So now, ladies and gentlemen, this is my test statistic right in here. This is what we did. We use the sample information to compute a what? Test statistic. What do you do with the test statistic? See where it lives on your decision rule. So, what do you guys know? Yeah, notice this. Like, I'll get out the pink again. Any test statistic that lives between these two numbers, the critical values, you do not reject the null. But any test statistic that lives where? Outside, you reject the null. So your test statistic is actually, I'm going to have to get rid of this because it's distracting me. You know where your test statistic is? Isn't it past? Isn't that negative 4 point what? 0.95. Isn't that the test statistic? Isn't that Z value? Isn't it past the critical value? It's in what neighborhood? What neighborhood is that? Do you guys know? Negative 4.95. It's in that neighborhood. Huh? What do you do? What do we do if it's in that? What neighborhood is it in? You reject the no. Isn't it in the reject the no neighborhood? Because it's past the critical value. This is not your conclusion, though. Who's been rejected? Has anybody here been rejected in your life? See, you got to know the meaning of that because people don't know the meaning of rejection. What is rejection? Huh? You've been pushed away? Has anybody been pushed away before? You're rejected? Well, what does it mean to reject the no? Where are you, no? Guess what, no? I am going to do what to you? You're rejected. You just rejected the no. What does that mean? Huh? What's that? You're what? Yes. Have you ever rejected anyone yourself? How about this? You got two choices. Person A, person B. If you reject person A, what does it mean about person B? Yeah. You guys get it? I'll say that again. This is the hard part for some people. I don't know if they don't understand what rejection means. Person A is rejected. Person B is what? What does that mean about the claim? A sample supports the claim. Outstanding. Why? The claim happens to be person B. You guys know. So that's why I write down the word claim. Because if you don't, you go, I have no idea what the conclusion is. This is why I put claim. What do? We're accepting the claim. So, formal conclusion. The what? Sample supports the claim. Who says those mathematicians aren't romantic? You say, well, that's not really romance. Maybe not. I don't know what you want to call it. Sample supports the claim. Okay? And it goes back to that very, very simple idea of rejecting and not rejecting. Okay? What do you guys think? Now, I'm going to kind of share with you guys something. See if I have it. I don't know if I want to share it with you. It's on the instructor's end. No, I don't have it. Whatever. Let me remind you guys of something here if I go back to the iPad. On a test, I just want you guys to note the things how I grade. Okay? What I always ask is people, the first question is always going to be, what is the claim? Okay? I want you to know what the claim is. The second question is going to be, usually it's, what are your critical values? The third question I like to ask is, what is the test statistic? And the last question I'd like to ask is, what is the conclusion? So as you go through the process, I want you guys to keep these key ideas in mind. What is the claim? What are your critical values? What is the test statistic? And then what is the conclusion? Those are the things I ask. I have a sheet you can look at. Oh no, maybe I can find it. Yeah, let me find it. What time do we get out of here? Okay, we got some time. Like if I had to do, you said, Mr. Judge, and by the way, just to talk about this, did I give you guys an estimation extra credit? When's it due? All right. And I asked you guys, somebody already in another class, he already actually turned it in. And I asked you guys to watch this and estimate the sample size, you know. But I can actually do another one. And you say, well, I got to find it. Where the hell is it again? No. Let me go to files. Jeez. E, F, G. I got hypothesis testing. I don't know if that's it. Let me see this. You guys at home can see me kind of upload this. This internet is a little bit what? It's a little bit weird down here. That's why your phones don't work. My phone doesn't work. And I didn't even get my coffee this morning. What a day already. Oh, there you go. Look at this. Didn't get my coffee today. Darn it. So I'm in bad shape. I forgot my phone. I had to drive back because I couldn't even get my email because they do a double authentication. So I need my phone. And then went back and left my coffee. Do you guys see what I'm saying here? Oh, it's a believe in Bigfoot question. Proportion of college students who believe in Bigfoot is not 25% as complained by Snodgrass. Sample of 500 college students reveal that 182 believe in Bigfoot. Use the 10% levels of ignorance to test the claim. What do I ask? What is the claim? What kind of test is this? Two-tailed test, right-tailed test, left-tailed test? What are the critical values? What's your test statistic? What's your conclusion? So I have you go through the hypothesis testing procedure for this. And here's another question. I might somehow assign that to you guys, maybe this weekend, because I want to keep you guys aware. You know what some people do is they don't do their homework, believe it or not. I know that sounds like a shocker to you. Some people don't do homework. They just don't. And this is on the homework. So I want you guys to get started. Oh, yeah. So let's put that there. You could get started. But I think I'm going to send that sheet as well. So all I'm saying is sometimes people just don't do homework. They copy answers and they turn it in like in middle school. They go, here's my work. Here's my answers. Well, how did I know that you did this? It's in the calculator. And then they miss everything on the test. So I can always figure out, I know what's going on. Mr. Judge wasn't born yesterday. It's 14. You guys see this? This is the T. No, that was what the video was about, to try to see. Yeah, that was trying to see if people can if people can watch a video. Anyway, I did put this in the chat already so that you guys know. Here's what we're going through. So, ladies and gentlemen, here's the thing about it. If I go to the iPad, we are testing proportions. Is that true? You guys remember? Are we testing proportions, I think? Hypothesis testing about a proportion. Is that right? Do you guys remember that? Okay, so here we go. Let's go over this here now. Did we do this example? 52% of newborn babies are boys. Nope, we didn't do that one. All right, so here we go. We're going to try this out, okay? Hypothesis testing about a proportion. What parameter is that, by the way? What, P? Is that right? So here's what they're saying now. 52% of newborn babies are boys as what? As claimed by who? Pediatric doctors around the world. So we're going to have to translate that statement. This is the claim, okay? So what does that mean? Right? That means your proportion equals what? 52%. And then this is the claim. Would you guys agree with that? So this is the meaning of your first sentence. So when you set up your hypothesis, remember this. You got two types of things to set up, right? Where does this statement belong? Right? We already looked at the process. We looked at an example. We're going to do another example here. So you have to remember, this is a null hypothesis, so we place it where? In the null position, because this involves a condition of what? Equality. So the null involves a condition of equality. You guys okay with that? Right? Don't blink. It'll be next week. All right, now let me say this. What's the opposite of this statement? P is not equal to what? 52%. Okay, now let's see if you guys remember from last week. Hopefully you guys do. What do I look at to determine what kind of test this is? We always look at the what? We look at the alternate hypothesis inequality. This is why I always put the eyeball here. Is that right? Okay, you guys okay with that? So when you see the not equal, what does that always mean? That always means what? Yes. It means you have a two-tailed test. Okay, so this is what you do. This is the process. This is a two-tailed test. So what do you guys want to draw a picture of then? You draw a picture of what? The bell with what? Two tails. So here's my what? Two tails here. Okay, so you draw your two tails. If you guys remember, this is a Z distribution with two tails. What goes, if you remember from last week, what goes in the blank space here? What goes here in the blank space? We say, yeah, what do we say? Do not what? Do not reject the null. And then the tails are, you're rejecting the null. Okay, so we're setting up our decision rule, but we're not done, because what do we need for the decision rule, right? You guys will be doing this next week. What do we need for that decision rule? Do you guys remember? You need to know those critical values. But how you get the critical values, they're going to tell you to do what? Use the what? 5% level of significance. So alpha is 5%. Okay. Now alpha is what's in your tails. Is that true? So if you have two, yes, each tail has what? 2.5%. Okay. So I move that 2 spaces. So you have 2.5% in each tail, because there's 2. So half of alpha is in the left tail, half of alpha is in the right tail. Okay, and we're not done with our decision rule, right? Remember this, we're not done with that. So How do I get my critical values, ladies and gentlemen? What did we use last time to get the critical values? Yeah, let me go back to my website because I'm going to remind you guys here of something important, okay? In the website, in statistics, I have a statistics summary sheet for you all. You know, one of the reasons I created this is because, again, on a test, you get to go back and you get to use this on your test and your final. So we're going to take a look here. Okay, I'm going to scroll all the way down. Yes, we have language. I'm going to scroll all the way down to, if you guys remember, this is hypothesis testing about a proportion. This is not what we look at. We're going to go over here. So how do we get our critical values is what I'm saying. What do you guys use? Inverse what? Inverse norm. If you guys remember, we were using inverse norm. So we got to go to the calculator. And in the calculator, remember this, right? We have to go to stat, distribution, inverse norm. This is going to give us the critical values in our decision rule. Now, how much of the bell is in the left tail? Isn't that 0.025? Yes, mu is 0, sigma is 1. Isn't that in your left tail? Is that true? 2.5% is in the left tail. So, what is the value there? Oops, now you say, I don't see anything. Oh my God. Let's go back. TI. Second distribution. What we did was go to inverse norm. This is going to give us our critical values. Now we put the 0.025 for 2.5%. Mu is 0, sigma is 1. Yes, it's a left tail. And so we get negative 1.96. Is that right? So what they gave you is this. This is negative 1.96. Now remember, this was the default for you guys who had the other calculator. Area to the left of the critical value is always the default. But remember, since you have two tails, what's the other critical value? It's going to be what? Yeah, it's on the other side of 0. It's symmetric.
So it's 0.025 for the area, 0 for mu, and then 1 for the alpha value, or 1 for the...
Alpha is 5%. Half of alpha is 2.5%. Well, on the TI, you had to put, for the area to the left, you had to put 0.025. Right? So this is what we put. Now, let's say, for example, you go, but Mr. Judge, I have the other calculator. I have that second distribution inverse norm. Well, always... this area, they don't give you the option of left, right, and center. It is always area to the left of the critical value. So you would have to put the 0.25 with mu 0, sigma's 1. And that gave you the negative 1.96 if you had the other calculator, which is exactly what we did here. So ladies and gentlemen, that's my point. You're looking at the default, and I did it with the same, setting there. So what is this thing called again? You guys remember? What do we call this? This is known as your decision what? Rule. So on that sheet of notes for you guys, I have exactly what you have to put in, This is your decision rule. Now, last week, if you remember, if we're going to compute our test statistic, because we are, we go to stat, what? Test, 1 proportion z-test. And then we need to know this what? This p-naught value, if you guys forgot. Okay, 1 proportion z-test. Anybody remember last week what p-naught was? What was last week p-naught? P-naught is the proportion in the null hypothesis. It is right here. This is our p-naught. So it's 52%. So we're going to now use the TI to compute the test statistic to see where it lives on our decision rule from last week, okay? So this is where the TI comes from. However, you need your what? Sample information. So you don't really go out and take a sample, although you would in reality. You just read that a sample of what? 1,000 births indicated 508 were boys. Now, what does that mean? A sample of 1,000, well, that's your sample size. 508 boys, that's the number of successes you had. So, you need to know that. N is 1,000 and X is 508. Ladies and gentlemen, okay, you're now ready to use the what? The TI. But what is it? 1 proportion Z what? Test. P naught, what was that? 52%. So now you're going to punch this in, ladies and gentlemen. You're going to punch this in. So you can go, remember, I'm saying you go to stat, test, 1 proportion Z what? Test. Okay. P naught, what do we say that was? 0.52. X, we had 508 successes. Good. 1,000 was the sample size. What kind of tail test is this? Is this a 2-tail test? So make sure it's on not equal there. Proportion not equal to P naught. Now you hit calculate. Now the second number, that Z value, that's your test statistic. Approximate that to the nearest hundredth. So what is Z approximately, ladies and gentlemen? Negative 0.7 what? 6. And then notice the sample proportion is 0.508, just in case. But the point I want to make here is this. Let's go back. We're trying to see where the test statistic lives on your decision rule. Negative 0.76. Now, any test statistic value that lives between your critical values of negative 1.96, positive 1.96, we do not what? Reject the null. So where does that live on your decision rule? Negative 0.76. It's right here. Is that right? So that lives between your critical values in the do not reject the null. Now, if it says do not reject the null, what does not rejecting really mean? You're going to keep the null. You're going to accept the null. Is that true? So by accepting the null, ladies and gentlemen, keeping it, whatever you want to call it, you're accepting that null, but you're getting rid of the alternate. But what does it mean about your claim? Yeah, you accepted the claim. Is that right? So that means that the sample what? Supports the claim. The sample information is suggesting that the proportion does in fact equal 52%, which is interesting because you would think it's 50%, but it isn't. So birth rates can actually not be 50-50. In this case, the sample information is suggesting that the birth rate is in fact 52%, as claimed by doctors. Now again, that's your second hypothesis testing question, ladies and gentlemen. And there you go. What do you guys think? Is that easy or is that hard? It's a process, it's a procedure, but science is important. Scientific method, really. And again, this is a summary of all the instructions that you guys put in there. Okay, we're going to do another one. Okay, now what does this say? The proportion of college students who take a full load is what? Is not what? Is not 40%. And then they say, as claimed by Snodgrass. So, what do we write down? P does not equal 40%. This is the claim by Snodgrass. This is what you're really testing. So you're testing that statement. Now, when you set up your hypotheses, where does that belong? Yeah. So this is a null hypothesis. How do you know it's a null? Does not involve a condition of equality. Okay, it's not equal. And yeah, now what you do is you say, okay, I got to look at the alternate hypothesis. I see a not equal there, right? I put the eyeball, and what do I notice? This is going to be a what? Two tail test. Whenever it's not equal, two tail test. So you're going to draw a bell with what? Two tails. Do not reject the null. And over here, we what? You reject the null. You what? Reject the null. But what do you need to know? What does it say? Use the what? Alpha is what? So what does that mean is in each tail if alpha is 10%? 5% and 5%. Okay, alpha is 10%, so half of alpha is 5. Now, 5% is written as 0.05. Is that true? So if you go to the calculator, what I'm going to do now, I'm going to go this time, we're going to go back to a nice fancy dancy. It's still second distribution inverse what? Norm. And now I put 5% is in my what? Left tail. Isn't 5% on the left? Sure is. What does this give you? Negative 1.645. If you go to the thousands position, now thousands for this number is just by tradition. And you have two values because you have a two-tail test. So I found my critical values. You guys okay with that? Okay. There's my decision rule, and I'm going to get rid of all this other stuff. All right. We take a sample, ladies and gentlemen. Once you have a decision rule, you take a sample. Let's read. What does it say about our sample information? It says what? Sample of 420 college students reveal 172 were enrolled in at least 12 units. So what is your sample size? Okay, what's 172 mean? Those are your successes. That's X. Okay. All right, ladies and gentlemen, what comes next? What do you guys remember? This information you're going to use in the TI. What are you going to use? One proportion what? Z-test. Don't forget, I think we need a mu naught. Is that true? Mu naught is always going to be the proportion in the null hypothesis. Sorry, P naught, 40%. We're going to get the test statistic. Second, clear. Stat, if I go to stat, right? Then go to test. One proportion what? Z-test. Oops, that's not it. Stat, test. Where's our one proportion? There we go, number 5. P naught is 0.40, ladies and gentlemen. Go down now to what are your successes? 172. What's the sample size? 420. Is that a two-tailed test? Here, calculate. What's your test statistic value going to be now? 0. Isn't that 398? Okay, 398 to the thousands. You say, why thousands? Because your critical value is to the what? Yeah, the critical value was to the thousands. Is that right? These are the critical values. So any test statistic between your critical values of negative 1.645 and positive 1.645, you do not reject the null. Now, this test statistic is in fact what? 0.398 is between 0 and 1.645, right? It's to the right of 0 because it's positive, but it's smaller than 1.645. What's the conclusion, ladies and gentlemen? You're looking at it. You do not what? Reject the null. What is not rejecting? You are what? accepting. You're not rejecting the null. By accepting the null, you're getting rid of the alternate. What did you happen to get rid of? You got rid of the claim. What's the conclusion if you got rid of the claim then? The sample does not support your claim. Why does the sample not support the claim? You got rid of the claim. It was crossed out. So, ladies and gentlemen, this is what you do. What do you guys think? Not too bad? Easy peasy lemon squeezy? It's a process you got to go over. Okay, here's the deal. At least what? 64% of college students believe Bigfoot is real, as claimed by what? Sociology professors. What are they saying, at least 64%? P, at least 64%. What does that mean, to be at least 64%? Greater than or equal to what? 64%, and that again is the what? Claim. So here we go. H naught, H1. P is greater than or equal to 64%, which is the claim, and P is under 64%. Okay? So don't we move that 64% to the null hypothesis? Is that right? Okay. Now, here's what I want to remark to you guys. Here's your eyeball. Where does that inequality point to? This is pointing to the what? To the left. Is that true? So this is not equal. So if you see this and it's pointing to the left now, this is known as a what? Left tail test. You guys see this pointing to the left? This is a left tail test. So now, here's the deal. Do not reject the null. And over here, you what? Reject the null. So on the left here, you're going to use the what? 1% level of significance. So if there's only one tail, okay, where does that alpha go to? It's all in the what? There's only one tail, ladies and gentlemen. So if there's only one tail, all of alpha is in this what? Tail. This is 1%. Okay, so there you go. Now, if you need a critical value, what do you guys do? If you had the default, right? We're going to get the critical value. You have the default. You go to the calculator here. I'm going to change it because you say, I already know how to do that when it's to the left. Okay. Go to second distribution, inverse norm, 0.01, area to the left. What is that test statistic going to be? Is that negative 2.33? Okay, now how many test statistics are there if there's only one left tail? There's only one, is that true? So here's the one and only critical value. You guys okay with that? It's right here. There it is. Negative 2.33. All right, now, this is your decision rule, ladies and gentlemen. It's a left tail test. So this is the first example of a left tail test for you guys. And it's very simple. The alternate hypothesis determines the tail. If it's pointing to the left, it's a left tail. If it's pointing to the right, it's a what? Right tail. So when you take your sample information, you have a sample of what? 400 college students revealing that 252 believe in what? Bigfoot. So you have a sample size of 400 with 252 successes. Okay, so we're going to say what now? The sample size equals what? 400. Number of successes is 252. So this is the sample information we need for the TI calculator, right? So the TI, 1 proportion z-test. But don't forget, why is this green? What does this mean here? Isn't this my P naught? 64%? So P naught equals that 64%, okay? That's going to be used in the TI. So we need a test statistic. We need to see where that test statistic lies on the decision rule. Okay? So let's punch this in. Here we go. Second, quit. Stat test. 1 proportion Z test, that's number 5. Is that right? Okay. P naught, 0.64 for 64%. $252. Sample size is 400. And then this is going to be a what? Left tail test. So make sure the inequality is pointing to the what? To the left. Hit calculate. What's your Z value? Negative point what? Negative 0.42. Is that true? Going to the nearest hundredths? Okay. So where does this live on your decision rule, ladies and gentlemen? Negative 0.42. Do you guys know where that lives? Any test statistic to the right of your critical value of a negative 233. We do not reject the null. So where is negative 0.42 at? It's going to be where? Right here, negative 0.42. And what does that mean? Do not reject the null. You don't reject the null. So if you don't reject the null, what are you busy doing? You're accepting the null. Is that right? The alternate is gone. So what does that mean about the claim? Yes, the sample supports the claim. Pretty simple. You say, why is the sample supporting the claim? Because the claim happened to be the null and you're accepting it. Yes? Yeah, the conclusion is always going to be either one of those statements. Either the sample supports the claim or the sample does not support the claim. Yeah. But I'm going to ask you for things like, what's the claim? What's the critical values? What's your test statistic? What's the conclusion? So that way I know you're doing the test. And then, I summarized everything here for you guys as well. Left tail test, negative 2.33. I even took pictures of everything here with the sample supports the claim, right? Okay, let's try the next one. You say, what's the next one here, ladies and gentlemen? Take a look. This one's going to be what? The proportion of individuals who take a second dose of COVID is what? Is more than what? 92%. As indicated by public health officials. So what does that P stand for? And more than is greater than. So P is greater than 92%, and then that is the claim. So where does this claim go? Where does it belong, ladies and gentlemen? Do you guys know, where is that going? Is that a null or is that an alternate? That's an alternate. And you say, how do I know? it does not have a condition of equality. It's an alternate hypothesis. The logical opposite is less than or equal to 90%. Okay, so you always look at, put your eyeball on the alternate hypothesis. And now, where is that pointing, ladies and gentlemen? Where does that point to? It's pointing to the right. What kind of test do you think this is going to be then? A right what? A right tail test. So draw your inequality here. Draw your bow to the what? Right. So do not what? Reject the null. Over here, you what? Reject the null. Now, in order to get your critical value again, what do you guys need to know to get that critical value? You need to know what? The level of significance. So they're going to say use the what? 1% level. What is this? Alpha is 1%. Level of significance is alpha. That goes down here. This is going to be your what? 1%. So 1% is down here. How do you represent 1%? Do you guys know? 1% is 0.0 what? 1. Is that true? Okay. So we need a critical value. And again, if I said to you guys, I'm going to go back and use the fancy dancy. So we're going to say second distribution, inverse norm, 0.01, and that's going to go where? To the right. Paste that in. What is the critical value going to be? 2 point what? 33. Okay, now be careful because I know what some of you guys are going to say. You're going to say, Mr. Judge, I have the default area to the left. Now, what is the area to the left if alpha is 1%? Do you guys know? This has to be what then? Isn't that 99%? Is that true? So 99% of the bow goes there. And you say, why do I have the other calculator? What's the other calculator? Well, when you go try it on the other calculator, you say, what's the other calculator? Stat, distribution, inverse norm. You put 99% and then hit what? Paste. You guys see how you get the same critical value? 2.33. So that's the default. Area to the left of the critical value is the default. And that's what some of you guys have. You guys have that calculator. Easy peasy lemon squeezy? What do you guys think? All right. So I'm just going to erase all this because, you know, we already got the information we need. We don't want to get distracted. This is our decision rule. We set up the hypothesis. So it's a right tail test. I'm going to get rid of that. So There we go. All right, ladies and gentlemen, let's go take our sample. You go, what does that mean? A sample of 1,200 individuals have taken the first dose. 998 received the second dose. What does that actually mean? What's your sample size? What's the 998? Isn't that the successes? That's X. So sample. Now go back. Sample here. $1,200. 998. So, ladies and gentlemen, what are you guys using the TI now again? What do you use? One. What is it? Proportion Z what? Z-test. One proportion Z-test. Don't forget, what do you guys need? I'm going to get out the green. The null hypothesis, 92%. What was this called? Isn't that P0? So what is P0, ladies and gentlemen? That's the 92%. That's in the TI. So I'm going to go over to the TI. Stat test. One proportion Z-test. P0 is that 92 we need. We need 998 successes. The sample size is what again? 1,200. What kind of test is this? It's a right tail test. Isn't this a right tail test? So we got to make sure that inequality is pointing to the right in our calculator. Hit calculate. And what is your test statistic, ladies and gentlemen? The test statistic, that Z value is the second number. What is that approximately? Negative what? 11.28 as a test statistic. So where is this negative 11.28? Isn't that to the left over here somewhere? Right? You guys know what I'm saying? It's negative. It's past zero. So let's read this. Any test statistic to the left of the critical value of 2.33, like in this case, we do not reject the null. What does that mean to not reject the null? It means you're accepting the null. But what are you getting rid of? The alternate, which happens to be what? So you got rid of the claim. So what's our conclusion? The sample what? The sample does not support the claim. So our sample does not support the claim. There it is, ladies and gentlemen. Easy peasy lemon squeezy. All right, we're going to give you guys a quick little break. Okay.